Yeah, so hey. I'm going to talk to you a little bit about ARKit and what I've explored in ARKit since it was announced at WWDC. First, I'm going to tell you a little bit about like the agenda for the talk. So why did I choose ARKit? And then I'll explain a little bit about how it works, which also like is kind of how a lot of augmented reality platforms work as well. And then I will specifically go into some of the APIs that you'll want to use if you implement ARKit in your own apps. And then I have like a pretty basic demo, but it works. It's pretty cool. So you'll get to see like some ARKit action happening on the stage. And then lastly, I learned a few things while I was working with ARKit, and so I will just like share some of those things that I learned, and hopefully you won't run into the same problems I ran into. So yeah, why did I choose ARKit? Well, this year was the first year I've ever been to WWDC. And so I was at the keynote, obviously, and I was like pretty unexcited about a lot of the announcements, as you can tell in the photo. And then Apple announced ARKit, which really got me interested. So then I was like really happy. And then, but I was actually really excited because I was one of the users who played a lot of Pokemon Go last year. Anybody else? Yeah. And so that's at least for me one of the biggest experiences with AR that I've ever had. So I was curious to what Apple has done for this. So in case you don't know what ARKit does, it's Apple's solution to allow you to implement an augmented reality experience in your own app for your users. And just in case you've not played Pokemon Go or used Snapchat filters or any of the other very popular augmented reality experiences, I'll just briefly explain what augmented reality is. So this is the image from the Apple documentation for ARKit, and the illustration of the living room is like the real world, and this little character guy is a virtual object that you place in the camera view to make it appear as though it's part of the real world. And that's what gives you an augmented reality experience. So now I'm going to like explain a little bit about how it works. And this is kind of an overview or a general overview of how augmented reality in general works. So one of the basic notions is there are these notable features that Apple detects in the video frames that are coming in through your camera. And these are called feature points. So I hope you can see the yellow dots in the image. And what's really important about these is that they're tracked between the video frames. So that's like a bit abstract. So I have like a cute little GIF of my dog that we'll use to demonstrate it. So this is my dog running through the office. And so for this example, we're going to assume that for some reason Apple determines that my dog is a notable feature and decides to detect him as a feature point. So what that would look like is like basically just like yellow dot running down the hallway. So using this information of feature points, you can then, so this is, pretend this like square is a feature point, and so now we can place an object there. And using the information about the difference between the position of the feature points between video frames, as well as a lot of the different information coming from the different sensors of your camera, or from your phone, so like accelerometer, et cetera, ARKit is able to determine what this object will look like as you move your phone around. So in the game world, is anyone else in games? Maybe? No one? Yay. OK, a couple people. OK, so in the game world, basically what Apple's doing is simulating moving the camera that projects your scene so that the objects look like they're actually in the real world. So it changes the position and the transformation of the object so that when I move my camera, it looks like the candle is actually there. So now we have a different perspective of the candle. So how do you actually get started with using ARKit? Well, I will at least tell you how I did it. There's an Xcode template that you can use, and it has like a lot of the basic setup for you. So you can use the augmented reality app template, and then once you do that, you'll have 3 different options of what you want to do. You can use SpriteKit, which is Apple's 2D game engine, or you can use Metal, which is like kind of like an OpenGL kind of equivalent, so pretty low level kind of thing, which I personally wouldn't attempt. Or you can choose SceneKit, which is the 3D game engine that Apple has, and that's what this example will use. Yeah, so after you do that, there's a couple lines of code that are really important. These are provided for you, but I will just explain them a little bit. Basically, to start an AR session, you need to have a configuration, which is this AR world tracking configuration. And that's basically just telling ARKit what to do and how to set up. And then you just run the ARKit session with that config. But that is actually like the pretty basic version of ARKit. Running, basically all that gives you is like the video feed from the camera in your view. To make it a little bit more interesting, we in particular today are going to work with plane detection. So basically all you do is like tell the session config that, hey, we want to be aware of horizontal planes that are detected through ARKit. And then you just run that session configuration. Then there's a couple of like delegate callbacks that you'll want to implement if you actually care about the information of detecting planes through ARKit. So the first one is ARKit will be like, hey, we detected an anchor, and in this case it will be a plane anchor, which carries a lot of information about the plane that's detected, which like is the position and the size, et cetera. So ARKit will be like, hey, we found a plane anchor, and do you have a node, which is a SceneKit object that you wish to represent this plane in some way, to visualize it per se. And so you're able to implement this method to tell ARKit, hey, I have this node, and please add this to the scene graph. And then another like important method is the update method on the anchor. So in our case, we'll be detecting planes or horizontal planes. And as you pan the camera or the phone around, it will start to actually update the size information of the plane. And so we'll use that information to update the visual that will be there. So those are the really, really important methods. There are a couple of like other delegate callbacks that you can choose to implement. Part of like important information is that like ARKit handles like the nodes for this, so you don't have to like worry about bookkeeping or anything. And then the last thing that our demo will actually do is add other objects. So ARKit would not be very fun if all you can do is detect planes. How do you add other objects? Well, it's like just as easy as in SceneKit adding a node to the scene. And for those who aren't game developers, it's kind of like just adding a view to the hierarchy. And then you can give them an anchor so that ARKit can keep track of them in the real world space. Now I'm just going to open my phone. Now I have a little demo, maybe. Before I open it up, hey, that's my dog again. His name's Albert, like Einstein. So before I open the app, I hope it works, but I'm going to explain a little bit. So it's like pretty basic. The UI is kind of like, I call it like a developer UI. There's nothing pretty about it. But there's a couple of switches. So there's a switch at the top to enable plane detection and to disable plane detection. And there's also a switch to enable and disable the viewing of the feature points, so the yellow dots. And I tend to like to disable that because, oh no, I broke it. I tend to disable the feature points because it gets pretty distracting. But like as soon as I open the app, it's going to get like really serious. So don't like freak out or anything. There's going to be like a lot of yellow dots showing up and everything. But what I'm doing is I'm detecting planes, and I'm basically going to simulate a hardwood floor on this nice black concrete floor. And as I pan around, you'll notice that the hardwood floor grows in size. So that's the update method. And then my cute objects that I add are just like cardboard boxes. And then as much as the cord will let me, I will like kind of walk around and look like a fool maybe, but let's see how it works out. Okay. So please let the lighting work. Sometimes you have to like move it around ever so slightly. Oh, look. Okay, we got two planes. That circle thing kind of throws it off. Oh, no, now we're just like one plane. Yeah, so I found some like really nice hardwood floor textures on the internet. Okay, and I really don't like the feature points. And then also Apple recommends that you turn off plane detection when you're done detecting planes, because as you can imagine, that's a lot of processing power being used to like do a lot of image processing there. Okay, so now we're going to have like some boxes. I'm just tapping on the plane. That's like kind of an important part for this demo. And then like Scene Kit gives us a lot of physics, which is why the cubes actually fall and then interact with each other. Now I'm going to like do some acrobats here. So now, oh gosh. Yeah, so now we can like inspect these boxes like really well. You know, we can see them from all sides. It's also really fun to show your friends this demo and like stand back and take photos, because I definitely did that to some of my colleagues. They kind of look just crazy. We can stack the boxes. My friend actually requested the feature to throw the boxes, so that's in the works. Yeah, so that's the demo. I also have a really nice cardboard texture that I found. It's pretty nice. Okay, that's the demo. Oh, maybe this works. And that looked like pretty fun. I can tell you that the first iteration of the graphics was also developer version. They were ugly. It was like just a gray, plain, one solid color, and purple cubes. And that was not pretty either. But now I'm just going to share a few lessons that I learned, maybe the hard way, maybe I just didn't read enough of the internet to figure them out on my own. But one of the most important things is that lighting is really, really important. I can't tell you how many nights I like waited too long to start working on the app, and then like the sun went down and it was like really dark in my flat, and my lighting's not so great in my flat anyway. So I'm like panning my phone around trying to see a feature point even, and it was so dark I couldn't like detect a feature point, let alone a plane. So I had to like figure out a different schedule of working on this app. It's also important to remember that converting from ARKit space to Scene Kit space, like you kind of have to do it. Otherwise, your Scene Kit nodes will be like not where you expect them to be or positioned the way you expect them to be. One of the big examples of that is actually Scene Kit geometry planes are actually by default vertical, so obviously you have to rotate them to make them horizontal. And then right now, as you saw, we were detecting horizontal planes, and that's for a good reason. They're the only thing that Apple has like baked into ARKit for detection. So I really hope that they enable vertical plane detection, and not only that, but to get like more complex, for us as developers to be able to provide more complex models, because the vision framework and also CoreML is now a thing. So maybe we could feed them some kind of like facial recognition model, and then like Snapchat could actually implement their facial recognition and filters in that way, or using ARKit. And then I would say like maybe it's still not the best. I still think it's pretty amazing that we have these like little devices hanging out in our pockets that can do all this computational power, where it's like actually processing images from a video feed at the same time. But I don't know if you could tell, but there's like a lot of kind of like jittery, and like the plane shifts a lot when you're panning around. And I also found this like amazing quote from the Apple documentation, which makes no sense. So I guess I will like file a bug report. But it says, "World tracking is an inexact science. This process can often produce impressive accuracy, leading to realistic AR experiences." And that was by far one of the highlights of working on ARKit, was finding this strange quote. And now I will leave you with like one last photo of my dog, who was very disturbed that I like somehow interrupted him in his sleep and placed a virtual candle next to his face. And the code for the demo is actually up on GitHub, and you can find it on GitHub.